Start recording. Good day. I will now give a short discussion on elementary logic. If you have confusion, you can just rewind the video to clear things up. So we go now to the slides. Module 9, Mathematical Logic. And these slides are prepared by Sir Michael H. Anikoy, and I am just using it. Okay, these are the module objectives. We skip this. These are the content of the lesson, the content of the module, I mean. And then we go to topic 1, logic statement and quantifiers. So we now go to our first definition. So what is a proposition? A proposition or statement is a declarative sentence which is either true or false but not both. The truth value of the proposition is the truth and falsity of the proposition. So we know in English that there are several types of sentences. There are question sentences, there are command sentences, and there are exclamation. And there are declarative sentences, right? Declarative sentences somehow speak about facts, but not necessarily all facts. It could include opinions. But a proposition must be first a declarative sentence, right? First, it should be, let me highlight the first requirement to be a proposition. First, it should be a declarative sentence, and it can be evaluated as either true or false. Otherwise, we cannot consider it. We cannot consider it as a proposition. Now, a proposition has two values only. That is, that value is called a truth value, and it depends on the truth and falsity of that proposition. So as an example, we have here to determine which of the following are proposition and not a proposition. So we go first to the first sentence. Manila is the capital of the Philippines. Now, looking at this statement, we know that it is a declarative sentence. So it passes the first criteria. And then we go to the next criteria. We ask ourselves if this statement is true or false, or can we evaluate this statement as either true or false but not both. Now, we know for a fact that Manila is the capital of the Philippines. So therefore, statement 1 is a proposition. So first, it is a declarative sentence, and we can evaluate it as true. Next is the second statement here, or second sentence. What day is it? Now, this is a question sentence, and we cannot evaluate it as either true or false. So this is not a proposition. We go to sentence 3, which states, help me please. So this is not, again, a declarative sentence. It is a command sentence or imperative sentence. So therefore, it is not a proposition. And number 4, we have somehow a confusing statement. It says, he is handsome. Now, the problem here for me, because I am a mathematician and I am strict with words, the word handsome here is somehow confusing, right? Because if we say that he is handsome, how do we know, right, that this statement is true? Now, there are several ways of giving a criteria to evaluate that someone is handsome or not. Now, the problem with handsome is that it is a vague word. It means that it is not specific, It is not specified because there are certainly different criteria for being handsome. So it is a opinion. So we cannot evaluate it as either true or false. So for me, number 4 is not a proposition. But for philosophers maybe, they consider this one as a proposition. So here we reveal the answers. So number 1 is a proposition. Number 2 is not a proposition because it is a question sentence. And number 3, it is not a proposition because it is a command sentence. But number 4, for philosophy people, they consider it as a proposition, but for mathematics, because of the ambiguity of the word handsome, we cannot consider this one as a proposition. Okay. The next is definition is propositional variable. So what is a propositional variable? A propositional variable is a variable which is used to represent a proposition. A formal propositional variable written using propositional logic notation are in small letters like P, Q, and R are used to represent propositions. Okay? So, suppose that we have our first proposition, the other slide, that Manila is the capital of the Philippines. Instead of restating that sentence over and over again, we use a propositional variable that stands for that proposition. Okay, so we might as well say that we let P, right? We let P be the variable that stands for the proposition Manila is the capital of the Philippines. Okay? So instead of saying the statement Manila is the capital of the Philippines is a proposition and its truth value is true, we instead write the statement P is true. Okay? So instead of restating or rereading the same sentence over and over again, we let a propositional variable, in this case P, to stand for that statement. Okay, and then we won't write the sentence over and over again. We just write its propositional variable. Okay, I hope that it's clear. If not, then it will become clearer as we go on in the discussion. Next, logical connectives are used to combine simple propositions which are referred as compound propositions. A compound proposition is a proposition composed of two or more simple propositions connected by logical connectives and or if then, not, and if and only if. A proposition which is not compound is said to be simple or also called atomic. Okay? So if it's not clear yet, it's fine. It will become clearer as we go on. Okay, as an example of this one is the first statement that Manila is the capital of the Philippines. That statement is a simple statement. But if we add another statement to it, then it will become a compound. So simply said, compound proposition or compound statement is just statements, more than one statements that are connected by these logical connectives and or if then, not, and if and only if. That's it. Now, there are three main logical connectives such as conjunction, disjunction, and negation. The following are briefly discussed in this section. Note that T here will now refers to true proposition and F will now refers to false proposition. So that means that a proposition has truth value, right? And then its truth value is either true or false. Now, instead of writing the word true, we write just T. And instead of writing F, we just write it as F. Capital T and capital F. Okay. So suppose now we have two statements, P and Q. And we want to combine them, these two statements, by the conjunction and. Okay? So here, this is the symbol here. Let me go to highlight. The symbol for P and Q is this one here. we have a wedge in between the two statements P and Q. So this is read as P and Q. Okay? Now, a simple statement or simple proposition has a truth value. It could be either true or false, but not both. Now, the same with a combination of propositions. Okay? The same with P and Q. So therefore, P and Q, the statement P and Q has a truth value also. Now, how to determine its truth value? Okay, if P is true and Q is true, then P and Q is true. Otherwise, P and Q is false. Now, this fact is summarized in this table in the right. Okay, so looking at this one, so we have if P is true, okay, and Q is true, the statement combinations combined by the conjunction and is again true. If P is true and the statement Q is false, we have the combined statement P and Q is false. If P is false and Q is true, the combined statement P and Q is false. And then if both statements P and Q are false, then the combined statements P and Q is again false. So that is, if we have a statement P and Q, it is only true if both statements are true. Okay, you can refer back to this table if it is not clear for you. Or you can rewind the video as much as you want. Now, there are common words associated with conjunction. P and Q, P but Q, P also Q, P in addition Q, P moreover Q. These are all the same statements, P and Q. An example, 2 plus 6 is equal to 9 and men are mammals. So, here, where's the pen? I can't find it. So here's the pen. We go to ballpoint. So we let, right? So to make this one simple, I mean to evaluate this combined statement in a simpler way, we convert the statements into variable, propositional variable, and then we look at the table. Okay, so we let P be the statement that 2 plus 6 is equal to 9, and then we let Q be the statement that men are mammal. I forgot the letter A, sorry. There you go. So if we convert it into symbols, we have P and Q. But we know that it is the statement 2 plus 6 is equal to 9 and men are mammal. Now, is the statement, right, P and Q true? Now, to evaluate its truth value, first, we ask ourselves, is P a true statement? That means, is 2 plus 6 equal to 9? Of course not, right? Because 2 plus 6 is not equal to 9, since we know that 2 plus 6 is equal to 8. So this implies that statement P is false. Okay? And then we move to the other statement, statement Q. Is Q a true proposition or statement? Now, we have here, men are mammal. Now, if we accept the reality that humans are animals, then this is true, that Q, men are mammal, is true. So this implies that by that biological explanation, we know that Q is true. So we now have So we now have the truth values of P and Q. Now, to evaluate the statement, or I mean the truth value of the statement P and Q, we go to the table. So first, we know that P is false. So we look at the table where P is false. And then we look at back again at the table where Q is true. Now, since the statement combined by conjunction P and Q is only true if both statements P and Q is true, it follows that the combined statement P and Q is false. So therefore, the statement that 2 plus 6 is equal to 9 and men are mammal is false. Okay? So that is. Now, we move to another example. Manny Pacquiao is a boxing champion and Gloria Macapagal Arroyo is the first female Philippine president. So first, we chop down these statements into two statements, right, combined by the conjunction and. So first, we let P to be the statement that Manny Pacquiao is a boxing champion, and we let Q to be the statement that Gloria Macapagal Arroyo is the first female Philippine president. Now, each statement must be evaluated. It could be true or false, individually. So first, is the statement P that Manny Pacquiao is a boxing champion is true? And the answer, yes, it is true. Manny Pacquiao is a boxing champion. And then we move to the second statement that Gloria Macapagal Arroyo is the first female Philippine president. Now, this statement is false, right? Because the first female Philippine president was Cory Aquino. Okay? So, in this case, the statement P is true. Okay? But our statement Q is false. So, again, the combined statements P and Q is false. We move now to another example. Abraham Lincoln is a former U.S. president and the Philippine Senate is composed of 24 senators. So our statement P here is that Abraham Lincoln is a former U.S. president, and the second statement is the Philippine Senate is composed of 24 senators. Now, if you don't know these details or these facts, you can just check it on Google, okay? So we let P to be the statement Abraham Lincoln is a former U.S. president, and Q be the statement that the Philippine Senate is composed of 24 senators. Now, statements P and Q are both true. Okay? If you are not convinced, you can Google this. Okay? Since both statements are true, so we have here the case that P is true and Q is true. Therefore, the combined statements P and Q is true. Okay. The next is disjunction. So, in the last slides, we have that we combine two statements P and Q using the conjunction and now we will now combine two statements P and Q using the disjunction or. Okay? The disjunction of the proposition P, Q is the compound proposition P or Q. So in symbols, here we have, and this is read as P or Q. Now, again, because this is again a proposition, it has a truth value. So how are we going to evaluate its truth value? Now, the truth value of this statement, combined statement, is again summarized in the table in the left. Okay? If both statements are true, then the combined statements are true. If one of the statement is true, the combined statement is true. And if both statements are false, then that is when the combined statement is false. Okay? So, to make your life easy, just refer to the table. Now, this is the common words associated with disjunction. The or word. Right? In this slide, it is only the or word. But maybe there are other things. Okay? So if these are multiple, more than two statements, usually these are separated by commas. And then, or for the last two propositions. But for now, we don't concern ourselves with that. Okay? So here we have an example. So the first example is 2 plus 6 is equal to 9, or Manny Pacquiao is a boxing champion. So to evaluate this statement, if it is either true or false, we again do the same as the disjunction example. The conjunction example. So we let P to be the statement 2 plus 6 equal to 9, and Q be the statement that Manny Pacquiao is a boxing champion. And then we evaluate the truth value of each statement. Now, the statement P, of course, is false, and then the statement Q is true. Okay? Now, because of that, the combined statement is true. Okay? Now, 2 plus 6, again, is equal to 8, not equal to 9, so that is false. And then Manny Pacquiao is a boxing champion is, of course, is true. Because in a disjunction, we only need one true for the combined statement to be true. We know that the statement P or Q is true. Okay. Another example. Philippine Senate is composed of 24 senators, or Gloria Macapagal Arroyo is the first female Philippine president. Now, we know that the Philippine Senate is composed of 24 senators, so therefore the first statement is true, while the statement Gloria Macapagal Arroyo is the first female Philippine president is false. So therefore, we have the statement that, okay, we have the statement P to be true and the statement Q to be false. So we look at the table where P is true and the statement Q is false. So we conclude that the combined statements P or Q is true. Next, another example. Abraham Lincoln is a former U.S. president, or man is a mammal. Now, we know from the last slides that Abraham Lincoln is a former U.S. president. So this is a true statement. And then man is a mammal is again another true statement. So we let P to be the statement Abraham Lincoln is a former U.S. president, and we let Q to be that man is a mammal. Now, given that both propositions are true, we look at the table here, we have that statement 2 is true and statement Q is true, so therefore we conclude that the statement P or Q is true. Next, negation. The negation of the proposition P is denoted by, okay, this is not a minus sign, it should be a tilde. Okay? Tilde. So this is denoted by tilde P, where the tilde symbol means not. Okay? And then, because again, not P is a proposition, it has a truth value. Okay. If P is true, then the statement not P is false. And then if P is false, then not P is true. This is summarized in the table here in the right part of our slides. As an example, first we have here common words associated with negation. Not P, it is false that P, and then it is not the case that P. Okay. Example. The following are propositions for P. Find the corresponding not P. Okay? So letter A, we have here 3 plus 5 is equal to 8. And then letter B, Sophia is a girl. And letter C, Achaia is not here. Now, letter A here, 3 plus 5 is equal to 8, is of course true. Right? Because you add 3 to 5, the result is 8. So, because that is true, its negation, 3 plus 5 is not equal to 8, is false. Okay? And then, for letter B, the negation of Sophia is a girl is Sophia is not a girl. Or, in simple English, Sophia is a boy. Okay? And then letter C, Achaia is not here, its negation is, it is not the case that Achaia is not here. So therefore, Achaia is here. Okay. Next, conditional. Another way of joining two propositions or combining two propositions to produce one proposition. The conditional or implication of the proposition P and Q is the compound proposition denoted as or read as if P then Q. In symbols, we have an arrow. So P, arrow, Q, where the arrow symbol is for if then. So P is called the hypothesis or antecedent or premise, and Q is called conclusion or consequent or consequence. Okay? The conditional proposition P implies Q is false only when P is true and Q is false. Otherwise, P implies Q is true. Okay? And this is summarized in the table in the right. Okay? So, if you have difficulty understanding this one, the best solution is to just memorize this truth table. Okay? You can do it. If P is true and Q is true, then the conditional statement P implies Q is true. And if P is true and Q is false, the statement is false. If P is false and Q is true, the statement again is true. And if both statements are false, then the combined statement P implies Q is true. Okay? So, I hope that helps. Common words associated with conditional. So, here we have FP, then Q, P implies Q, or P only if Q, P therefore Q, P is stronger than Q, P is sufficient condition for Q. But we will just use F then Q, or P implies Q. Okay. So here we have an example. If vinegar is sweet, then sugar is sour. So first, we should determine the statements P and Q. So this one here is the statement P, and the statement here is the statement Q. Okay? So we have here, P is the statement vinegar is sweet. It should not contain the word if. Sorry about that. It should be vinegar is sweet. And then statement Q is sugar is sour. And then we need to evaluate each statement. So the statement that vinegar is sweet is of course false. And then the statement Q, sugar is sour, is of course false. Okay? Now, we know that both statements are false. Then we look at our table here. If both statements are false, then the combined statement P implies Q is true. So therefore, the statement if vinegar is sweet, then sugar is sour is true. Another example. 2 plus 5 equal to 7 is a sufficient condition for the statement that 5 plus 6 is equal to 1. Okay? So, it's a sufficient condition. That means that 2 plus 5 is equal to 7 implies 5 plus 6 is equal to 1. So, first, we determine the statements P and the statement Q. So, 2 plus 5 equal to 7 is the statement P, and Q is the statement that 5 plus 6 is equal to 1. Now, we evaluate each statement. Now, 2 plus 5 is equal to 7 is, of course, true. And the statement that 5 plus 6 is false, right? Because 5 plus 6 is 11, which is obvious. So, we have a statement true implies false, okay? So, to check or to evaluate this combined statement, we need to refer to the table, the truth table. So looking at the truth table, we see that our statement P is true and the statement Q is false. So therefore, the combined statement is false. That is, the statement P implies Q is false. So 2 plus 5 equal to 7 is not a sufficient condition that 5 plus 6 is equal to 1. Okay. Next, another way of combining two statements is called biconditional or double arrows. The biconditional of the propositions P and Q is the compound proposition P if and only if Q. Now, symbolically, P if and only if Q, where these double arrows here, left and right arrows, that one there is stands for the phrase if and only if. And to evaluate the truth value of the statement, we look at the table at the right. Okay? If P is true and Q is true, then the combined statement P if and only if Q is true. And then if both statements P and Q are false, then the combined statement P if and only if Q is again true. In all other cases, it is false. Okay, you can memorize this table. Okay, common words associated with biconditional. P if and only if Q. Or in short, you can just write IFF. It is the same as P is equivalent to Q. Or P is necessary and sufficient for Q. Now, the simpler way to say this one is P if and only if Q, and P is equivalent to Q. Okay. Example. 2 plus 8 is equal to 10 if and only if 6 minus 3 is equal to 3. The first step is to determine the statements P and Q. So our statement P here is the statement 2 plus 8 is equal to 10, and our statement Q is 6 minus 3 is equal to 3. And then we need to evaluate the truth value of each statement. Now 2 plus 8 is equal to 10 is true. And then 6 minus 3 is equal to 3 is again a true statement. So therefore, this statement is true. The biconditional statement that 2 plus 8 is equal to 10 if and only if 6 minus 3 is equal to 3 is a true statement by just looking at the table here, no? This part. Next example. Manila is the capital of the Philippines is equivalent to fish live in the moon. Now, our statements P here is Manila is the capital of the Philippines, and then our statement Q is fish lived in the moon. Okay? Obviously, Manila is the capital of the Philippines is true. So our statement P is true, and our statement Q is false because, I don't know, in my knowledge, there are no fish that live in the moon, right? So this statement is false. So in conclusion, we have statement P is true and statement Q is false, and therefore the combined statement, Manila is the capital of the Philippines is equivalent to fish live in the moon is false. Okay. Another example, 8 minus 2 equal to 5 is a necessary and sufficient for 4 plus 2 is equal to 7. Our statement P here is 8 minus 2 is equal to 5, which is false. And then another statement that 4 plus 2 is equal to 7 is again false. So we look at the table here, and then we can conclude that the whole statement is true. Okay? False if and only if false is true. Okay. So I hope that it's clear. Now, what we have just discussed are combinations of two statements only, right? We combine them using the conjunction and the conjunction or, and then we have another operation, the operation called negation. We negate the original statement. Now, those are for two statements only, but we can extend them to multiple statements, more than two statements. So that is, we can combine more than two statements. Okay? Again, since combination of statements is again a statement or a proposition, then it has a truth value. Now, the question is, how are we going to demonstrate the truthness or the falsity of a complex statement? Okay? So we need to construct its truth table. How? We are going to use the past tables. Okay, the tables for and, or, and not, the implication, and the biconditional if and only if. Okay, we move to an example. This section shows the construction of compound propositions through truth tables, which referred as standard table form. So let us construct the truth table for each of the following proposition. So the first proposition here is the statement not P or not Q. So how are we going to determine its truth value? If both P and Q are false, is the statement false or is it true? If both statements P and Q are true, is the combined statement true or false? If one of them is true and one of them is false, is the combined statement again true or is it false? Now, to answer that question, we are going to construct its truth table. Okay, how are we going to proceed? So the statement P has two possible values, true or false, and then Q has two possible truth value again, true or false. We construct their combinations. So the first combination here is true, true. Another combination is false, true, false, false, true, and false, false. Now, the easiest way to construct this combination is to make a decision tree. Okay, so you write P here, and then of course P can have two values, true or false. And then you go to another statement Q. So Q has two possible values, true or false. So you make branches from T, you move to Q, and then from T you move to F, and then we put T and F again. We move F to T, and then F to F. So we write their combination as true, true. This one here as true, false. Okay, you just trace the arrows, and then by tracing them and then listing each of this combination, you now have all possible combinations of truth and false for the statements P and Q. So this one here is FT, and this one here is FF. So that's how you list all possible combinations, a decision tree. Okay, now we need the column for not P and then the column for not Q. Now, according to the negation table here, this one here, the negation table, if your statement P is true, then its negation is false. So you write here F. Okay? And then we move to the next value, which is T. So again, this is false. And then we move to another value here, F. And according to the negation table, if P is false, then its negation is true. So this one here is true, and then F here becomes true. And then if you move to the Q column, you just replace Q here. Okay? You replace P with Q. So from there, we see that the true value, okay, the true value, where is it now? We move. Okay, so since Q is true here, its negation is false, and then Q is false, its negation is false. Q is true, its negation, sorry, it should be true. Okay, this one here, where's the eraser? Eraser. Okay, anyway, so this becomes true, and then this one becomes false, and then this one becomes true. Now, the next column is the final proposition, not P or not Q. Now, to solve this one, you need to put some open and close parentheses here. Okay, so to solve this column, we go to the OR table here. This is the OR table. Okay, OR. The other one here is not, the not table. Now, according to the OR table, if both statements are false, then the combined statement is false. So since here we have false and false, so this one here is false. So here we have false, we have true. So based on the table, we have this one is true, this one here again is true, and this one is false, so this one is true. And both statements here are true, so the combined statement is true. Okay, we move to another example. This one here is a bit complicated than the first example. So what we do is we break down this statement. Okay, so our first statement that we need to evaluate is the not Q, and then the combination P if and only if Q, and then the final combination. Okay, so we can now evaluate this one. Not Q. So since Q is true, this one becomes false, this one becomes true, this one becomes false, and this one becomes true. Okay, and then we move to the second column. P if and only if not Q. Now remember that a biconditional statement is true if and only if both statements are true or both statements are false. So we can confirm that one by looking at this table here. Okay? So P if and only if Q. True and false is false. True and false is false. True and... Okay. P and not Q. Okay, that is fine. So true and false is false, true and false is false, false and true is false, and false and false is true. Okay? And then we move to the implication. So we just look at the implication table here. This one. The implication table. So looking at P, we have the statement P is true. The first row, okay? We now look at the first row. This one here is true, and then this one here is false. So true implies false, true implies false, and the statement is false. So this is false. Again, true implies false, so this is again false. Then false implies true, false implies true is true. So this one here is true. And then false implies false is true by looking at this part of this table here. So that one is true. So that's how we are going to decide if a complicated or complex statement is either true or false by looking at first by constructing its truth table and then looking the possible values. So you do the other examples here. Now, we move to equivalent statements. Two propositions are said to be logically equivalent or equivalent if they have the same truth value for every row of the table. That is, x if and only if y, or x is equivalent to y, is a tautology. Or symbolically, we have here x, okay, x, this one here, that is the symbol for being an equivalent. So here, we read this one as x is equivalent to y. So example, show that the following are equivalent. So we want to show that the statement P and Q or R, statement here, is equivalent with the statement. Now, according to our definition, this statement are equivalent if their truth values are the same, right? For every row of the truth table. So how are we going to show that these two statements are equivalent? we construct their truth value. The same as the past slides. So here, so of course, by constructing them, we have Q or R. So this one here is true, 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 false, true, 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 false. And then we move to the next column, P and Q or R. So since we're now looking at AND, a statement joined by AND is false, or it is only true if both statements are true. So P is true and Q or R is true, so therefore this statement is true. Okay, similarly, this statement here is again true, this statement here is again true, and this statement here, because we have true and false, so this is false. We have false and true, so this is false. We have false and true, again false, false and true, this is again false, and false is false. We now move to the statement P and R. Now, P and R are both true, so this is true. T and F, so this is false. This is true, this is false, this is false, this is false, this is false, and this is false. Okay. So we replace this one with Q, P and Q. So this is true, this is true, this is false, 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 and this is false. Okay. We now move to the statement P and Q or P and R. So again, this is combined by OR. So we already have the statement P and R and the statement P and Q. So what we need here is now complete in the previous columns. So this is OR, sorry. So it becomes true or true is true. And then false or true is true. True or false is true. False or false is false. False or false is false. False, false, false. Now, how do we know that these two statements are equivalent? Now, to know is to check the columns. Okay? So we look at this column here and this row here, we have a true statement, and then we have a true statement here. We move to another row, so this is true and this is true. We move to another row, this is true, this is true. We move to another row, false, false, again false, 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 and another false, false, and another false, false, and another false. Now, since all the values in this column here, and this column here, their values on each row are the same, we conclude that these statements are equivalent, or they are logically the same. Okay? In short, if you look at this one like an arithmetic in elementary, we can conclude that the operator or the disjunction AND can be distributed over the disjunction OR. Okay? It is the same as a elementary algebra. Distribution over addition. Now you do the other example to practice yourselves. Okay? So the next topic is tautologies and contradiction. So there are three important classes of compound statements, namely tautology, contradiction, and contingency. So what is a tautology? A tautology is a compound statement that is true for all possible combinations of the truth values of the propositional variables, also called logically true. So what does it mean? It means that in all possible values, the truth value of that compound statement is true. Okay? Whatever reality is, that statement is always true. Next is a contradiction. It is a compound statement that is false for all possible combinations of the truth values of the propositional variables, also called logically false or an absurdity. Absurd. Okay? So this statement, no matter what is the reality, this statement is always false. Now, another example is contingency. So it is a compound statement that either true or false, either, depending on the truth values of the propositional variables. So it is a neither tautology nor a contradiction. A contingency is somehow dependent on the input. For example, if we say, today is rainy, or today is raining. Now, if we are talking this specific day, and then you look outside, if it is raining, then that statement is false. But if you read that statement again on the other day, okay, or after a few months, you read that statement, today is raining, and then you check outside, and it is not raining, then that statement is false, okay? So that means that the truth value of that statement depends on what day it is. So it is a contingent. You can evaluate this statement as either true or false, but it depends on something. Okay, it depends on an input or an argument. Okay, we move to topic 3. Conditional, biconditional, related statements, and symbolic arguments or rules of inferences. There are different ways to express the conditional proposition P implies Q. The conditional proposition P implies Q can be expressed in 3 variations using the logical connectives, negation, and implication. Okay? So we have here the usual conditional P implies Q. Okay? So that is the usual conditional P implies Q. An equivalent of that is called the converse of the implication. Converse. No. The converse is not equivalent to its original statement. Okay? I mean, if you reverse the rules, okay, if you now Q implies P is called the converse of the original statement P implies Q. Okay? The two statements are not the same or not equivalent. Another way is the inverse of P implies Q. So this is written as not P implies not Q, and then the contrapositive of P implies Q is written as not Q implies not P. Okay? The contrapositive of P implies Q is equivalent to P implies Q. So they are the same. Okay, example. Given the conditional proposition, if Akeya goes to school, then Sophia will go home. Determine the converse, inverse, and the contrapositive of the proposition. So, to solve this problem, we first need to determine our statements P and Q. So, we let P, Akeya goes to school, and Q, the statement Sophia will go home. Okay? So, we now need to find its converse. So the converse is Q implies P. So it will become, if Sophia will go home, then Akeya goes to school. Its inverse, not P implies not Q, can be is read as Akeya does not go to school, then Sophia will not go home. And it's in contrapositive, if Sophia will not go home, then Akeya does not go to school. Okay. Now, we move to the application of those we have discussed. So, we are now in symbolic arguments. So, a proof, right? If you have a claim or a statement that we claim as true, then we need to justify it. Okay? We need to convince someone or people that our claim is true. Okay? As an example, if you say that it is raining today, then how to convince the people that it is in fact raining today. Okay? What you do is you look outside and confirm that it is raining. So that is a proof, right? A proof that to the claim that it is raining today. Now, if we have a very complicated statements, we need standards, okay? Or flow, a flow of reasoning, okay? That flow of reasoning is here depicted in symbolic arguments. Okay. So first, let's discuss what is a proof. A proof is an argument from hypothesis or assumptions to a conclusion. So it's a flow from the hypothesis or given to the conclusion desired. Okay. Each step of the argument follows the laws of logic and rule of inference. In mathematics, a statement is considered valid if it is accompanied by a proof. Okay? Proof is one of the important things that make mathematics different from other disciplines. It is not easy to establish proofs. There is no single guideline for proofs, and it is not just following rules, memorizing formulas, or even looking at some examples in text. In fact, they consider proof writing as an art. Okay? Most of the rules of inference are from tautologies. Since a tautology is a statement which is always true, it is used in drawing conclusions. Logic proofs usually begin with premises or assumptions, statements that are allowed to be assumed, while conclusion is the statement that needs to be proven. The idea is to make use of the premises using rules of inference until we arrive at the desired conclusion. The arguments can be written in symbolic form, which will be discussed in the following examples. So these are, the common, right? These are the common valid arguments or rules of inference. There are several, but in our case, we just go with 4. So here we have what we call modus ponens. Okay? Modus ponens. So the premises are P implies Q, therefore Q. Okay? You can read this one as, suppose that the statement P is true, and that the statement P implies Q is true. Therefore, the statement Q is true. Okay? That is called modus ponens. Another is law of syllogism. P implies Q, and Q implies R. So therefore, P implies R. Okay? So suppose that the statement P implies Q is true, and the statement Q implies to R is true. So therefore, the statement that P implies R is true. Okay? Somehow, if you look at this one, it's like transitivity of the implication. Next is modus tollens. If the statement P implies to Q is true, and the statement not Q is true, therefore the statement not P is true. Okay? Next is disjunctive syllogism. P or Q is true. If not P is true, that means that the statement P is false, but since the statement P or Q is true, it must be the case that the statement Q is true. Okay? Now, if it is very hard to understood, then what you do is memorize these tables here. Okay? Or in our quizzes and exam, you can use tables. Okay? I will provide tables to make it simpler for you. We move to the first example. We will use modus ponens. Okay? So if P is true and P implies Q is true, therefore the statement Q is true. So our first given here, suppose that Sophia wins 20 million pesos prize in Lotto. Okay, so we assume that statement is true. And then we assume another statement. If Sophia wins the 20 million peso lotto prize, then Akia will put up a business. So therefore, Akia will put up a business. Okay? So how do we make sense of this very complicated statement? Okay, this statement here, this is our statement P, right? So this one here is our statement P. And then this other statement that Akia will put up a business is another statement. So that statement is Q. Okay? And therefore, Akia will put up a business is statement Q. Now, looking at the modus ponens, okay, we see that the statement P here is Sophia wins 20 million peso lotto prize, and then the statement P implies Q is the statement Sophia wins 20 million lotto prize, then Akia will put up a business here. Now, since we have that form P and P implies Q, we conclude that the statement Akia will put up a business is true. Okay? So if this is not clear, you can go to the internet, you can go to YouTube and find many examples there. Okay? Now another example is using the law of syllogism. So here we have P implies Q and Q implies R. If 18 is divisible by 6, then 6 is divisible by 3. If 6 is divisible by 3, then 18 is divisible by 3. Therefore, using the law of syllogism, if 18 is divisible by 6, then 18 is divisible by 3. So, this statement is P implies Q, and this statement is Q implies R. Okay? And this statement here is Q implies R. Okay? That argument is valid using the law of syllogism. Another example is modus tollens, and then disjunctive syllogism. Okay? Now, you can read this one on your own. Okay? So, just read them. Next, we will now discuss fallacies, right? Fallacies. It means that these are statements that are false, okay? And how to determine if we are using a fallacy. So, logical fallacies refers to faulty reasoning in logic of an argument. It is advantageous to know logical fallacies in order to avoid them in an argument. There are different types of fallacies that we might use to present our position. The following are the list of common types of fallacies with their corresponding examples. An example of a fallacy is called ad hominem, right? The ad hominem means you criticize the person that gives the argument instead of the argument that the person provides, right? Example to that, you are ugly, or you are short, your nose is flat, right? That is a personal attack to the person. You are not attacking his argument, but rather you are attacking his personality or his humanity. And that is a fallacy. And you should always avoid that one to avoid arguments, violent arguments. Okay, the first one is called appeal to authority or argumentum ad verecundiam. It is an argument that occurs when we accept or reject a claim merely because of the sources or authorities who made their positions on a certain argument. So, usually, if a person has a authority, we believe what they say, even though what they say might be false, right? Sometimes we don't evaluate their statements. We just accept them as truth. Okay? So that is a fallacy. That is called appeal to authority. As an example, we have here, the government should not impose death penalty. Many respected people, such as the former Secretary of Justice, have publicly stated their opposition to it. Now, why is this called an appeal to authority? Because we believe that we should not impose death penalty because someone with authority said that we should not impose it. In this example, the Secretary of Justice. Not because the Secretary of Justice, the former Secretary of Justice said that we should not impose death penalty. It doesn't mean that we should not impose death penalty. We should criticize his or her argument first before accepting that one as truth. Okay? Another example, Floyd Mayweather signs autographs with Parker pen. So evidently, Parker pen is the most reliable pen on the market. So the claim here is that Parker pen is the most reliable pen on the market. What makes Parker pen the most reliable pen on the market? Because Floyd Mayweather signs autographs with Parker pen. Now, does it make the claim valid that Parker pen is the most reliable pen because Floyd Mayweather used it in signing autographs? Of course not, right? It is only an opinion of Floyd Mayweather or the person who wrote this statement. Okay? So this is a fallacy. Okay? The person with authority here is Floyd Mayweather. Okay? Floyd Mayweather can say opinion, but we should not believe what he said. Okay? We should not accept his statement as truth. We should first criticize them. Now, another fallacy is called appeal to force or argumentum ad baculum. It is an argument which attempts to establish a conclusion by threat or intimidation. Okay? You intimidate the person that you want to believe your statement. Okay? By giving them threats or to intimidate them. An example, you will support my idea and tell the others that I am right because if you don't, I will do everything for you to lose your job. Right? So, this person is threatening someone that if you do not believe his ideas and to tell others that he is right, you will lose your job. It's a threat. Or he is applying force for you to believe his ideas. So it is called appeal to force, and that is a very bad argument, and in fact it is very common here in the Philippines. Even the politicians use this fallacy every time. Another example, if you don't believe in God, you won't go to heaven. Okay? This is a threat. The threat here is that you won't go to heaven. Everyone is afraid of hell, right? Do you know someone who like to go to hell? Of course, no one, right? So this is a threat. You won't go to heaven if you don't believe in God. Okay? So this is a very bad argument for people in religion. You should not force people to believe in your God by telling them that if you don't believe in my God, you will go to hell. Okay? That is a very, very bad argument. You are forcing someone to believe in your God because if they don't, you are sure that they will go to hell. Okay? You cannot convince people in that way anymore today. Okay? Another example is appeal to ignorance or argumentum ex silentio. It is an argument supporting a claim merely because there is no proof that it's wrong. Example number 1. Since time, people have been trying to prove that God exists, but no one has yet been able to prove it. Therefore, God does not exist. Okay? So, this is, again, a fallacy. Okay? Not because there was no, or there are no people yet been able to prove the existence of God. It doesn't mean that God does not exist. No? God might exist. We don't know yet. Okay? Okay. This is a very dangerous topic. We move to example 2. If you can't say that there aren't Martians living in Mars, so it's safe for me to accept there are. Okay? So, here, what is in question is the existence of Martians living in Mars. Okay? So, since there are no evidences or no one is able to or was able to say that there aren't Martians living in Mars, you cannot accept directly that there are Martians living there. Okay? Another example, appeal to pity or argumentum ad misericordiam. It is an argument that involves an irrelevant or highly exaggerated appeal to pity to get people to accept a conclusion by making them feel sorry for someone. Okay? In short, you act like a victim so that the people that you are talking to will believe in you. Okay? That is a fallacy that is called appeal to pity. An example, Mark has worked hard on his research project and he will be depressed if he fails. For these reasons, you must give him a passing grade. Now, the appeal to pity here, the part appeal to pity, is the statement, he will be depressed if he fails. Okay? He used as a reason to pass Mark because he might get depressed if he fails. Okay? Emotion. Appeal to emotion. Another example. The city engineer is a vital part of this city. If he is sent to prison, the city and his family will suffer. Therefore, you must find in your heart to forgive him. Now, this is a very, very common fallacy in making negotiations. For example, if both parties are asked to go to barangay captain to settle problems down, most people will appeal to pity or appeal to emotion, right? There is nothing bad there, but if you are in a formal debate or formal discussion, that should not be used. Okay? So, as an example here, if you put the city engineer in the prison, then the city and his family will suffer. So, he used his family and the city to propose, right? To propose that the city engineer must not be put into prison, and that you must find in your heart to forgive him. Another example, appeal to the people or argumentum ad populum. It is an argument that the opinion of the majority is always valid. Okay. In short, this is a societal pressure. Not because the society said that you should do this one, you should do it, even though it is wrong. Okay? Or not because everyone is doing it, you should do it, even though it is wrong. So that is called an appeal to the people. Okay? Filipinos are very good at this one. Right? Example number 1. Most Filipino like soda, therefore, soda is good. Okay? Not because all Filipinos like soda, then soda is good. In fact, soda is considered as a junk food. Example number 2. Everyone I know is voting for Juan de la Cruz. So he's probably the best choice for mayor. Now, not because everyone is voting for Juan de la Cruz, he is the best choice for mayor. This is not always true. It could be the case that they vote for Juan de la Cruz because Juan de la Cruz gave them money, right? Or gave them favors, which is, in fact, very common here in our country. Okay? Fallacy number 6. Argumentum ad hominem, or Latin for to the man. It is an attack on the character of a person, of his opinions or arguments. It is a tactic used by an adversary when they do not have a logical counter-argument. So suppose you have two persons, the other one is very logical and the other one is not so logical. He made a claim, the other one made a claim, and since the other one cannot counter argument or give an argument making the other argument false, he will attack the person. Okay? Not attacking in physical form, but his character, the character of the person, or the humanity of that person. Okay? As an example, he will insult the person of having a black skin, or being short, or being ugly. Right? That is called an argument ad hominem. As an example, don't listen to Peter's assertion on instruction. He's a simpleton. So this is an attack on the character of Peter, that Peter is a simpleton. Instead of giving an argument why he should not listen to Peter's assertion, he attacks Peter's character of being a simpleton. Right? Insulting other people because you cannot provide a counter argument. That is a fallacy. Another example, you can't believe that presidential candidate is going to lower taxes. He's a liar. Now, so this one here, it is attacking the character of the presidential candidate, that he is a liar. Now, instead of giving a solid argument, he attacked the character of the presidential candidate. Another fallacy is called circular argument or petitio principii. If a premise of an argument presupposes the truth of its conclusions, meaning the argument takes for granted what it's supposed to be proved. Example number 1. Senator Chis Escudero is a good communicator because he speaks effectively. Now, why is this is called a circular argument? This statement here wants to show to us that Senator Chis Escudero is a very good communicator. So what does it mean to be a good communicator? If you speak effectively. But if looking at the statement, you see, he uses the definition to show that Chis Escudero is a good communicator. Okay? This is circular because good communicator and speaks effectively are synonymous. They are the same, right? You use it as a premise or as an assumption, and then you use it, but then it is the conclusion. Okay? The conclusion and the assumption are the same. So why prove if you assume it to be true? Another example. God exists because the Holy Bible says so. Okay? The Holy Bible is true. Therefore, God exists. Okay? This is circular. Okay? Because it says here that God exists because the Holy Bible says so. So the Holy Bible is true. Therefore, God exists. Now, the problem here is that you use the book, the Holy Book, to show that God exists. Okay? But then, you won't see anything there saying that the God does not exist in the Holy Book. Okay? So, this is circular because the Holy Bible will not say that God does not exist. Okay? But instead, you should use references outside of religion or outside of the Bible. Maybe you look at the history or you go to places. Okay? And you should not use the Holy Bible. And again, we should not go farther from here because this is very sensitive topic. Another fallacy is equivocation. It is an argument used in two or more different senses, meanings within a single argument. An example, giving financial support to charity is the right thing to do. So, charities have the right to our finances. So, there are two different meanings for the same word. Okay? Financial support. Another example, some real numbers less than any number. Therefore, some real numbers are less than itself. No, of course, obviously, this is false. Another example is fallacy of division, a reasoning which assumes that the characteristic of a group is also the characteristic of each individual in the group. Okay? So, this is, again, another fallacy. As an example, University of the Philippines is the best university in the country. Therefore, every student from UP is better than any other university in the country. This is false. Okay? Majority of the UP graduates are good students or best students or best graduates, but it doesn't mean that every graduate or every student in UP is better than any other university. Okay? It's just the case that they produce the best, but it doesn't mean that every student are the best in that university. So in that case, in fact, the university will almost not matter. Another example, your family is crazy. That means that you are crazy too. This statement is again false because, as an example, as a joke, there is a family and they are all crazy. Okay? Does it mean that they are all crazy? And the people said, yes, they are crazy because crazy is their last name. So therefore, they are all crazy. This is a Bisaya joke, but they make it into an English joke here. Okay? Or if a family has an illness, it doesn't mean that each member has an illness too. Another example is false dilemma. It is an argument which implies one or two outcomes is inevitable and both have negative consequences. But actually, there could be more choices or there are other possibilities. So, you did not consider other possibilities. If you don't vote for this candidate, you must be anti-Christ. Okay? This is very common for people to be in religion. So, if you don't vote for this candidate, you must be antichrist. Why? So you mean there are only two choices, pro-Christ and antichrist. You forgot that there are people that don't believe on Christ, right? Christ, right? Christ is the name of Jesus Christ for people that believes in Christ, or the religion are Christianity. He forgets, or this person forgot, that there are other religions too, like Hindu, or being a Jew, right? Or being a Muslim, or being a Taoist, or being a Buddhist, or there are even people that don't believe in religion, or believe in God. They just believe in spirituality. But here, he made a conclusion that if you don't vote for this candidate, then you must be an antichrist. This is false. It could be the case that he is a Muslim or he is a Hindu or in other denominations. So you forgot the other options. You either broke the glass door or you did not. Which is it? This one here. Did it miss other options? Well, yes. I don't think so, because there are two cases only, either breaking a glass or not breaking a glass. Okay, you can do this one. Another fallacy is hasty generalization. It is an argument that a general conclusion on a certain condition is always true based on insufficient or biased evidence. Example, a MacBook broke after a month, so there must be something wrong in the manufacture of MacBook. Not because one MacBook broke, it doesn't mean that there is something wrong in the manufacturing of MacBooks. Okay? If this is true for one person, it doesn't mean that it is true for the whole group. Okay? It is like an induction. Okay? So this is why induction cannot be trusted. Okay? Because induction is only based on specific examples but not on the entirety. Example number 2, my cousin said that mathematics subjects were hard and the one I'm enrolled in is hard too. So this made a conclusion based on one's observation. So this is like a induction. So that's why induction cannot be trusted as a proof. Next is red herring. It is an argument which introduces a topic related to the subject at hand. It is diversionary tactic to avoid key issues, often way of avoiding opposing argument rather than addressing them. So example, some politicians may be corrupt, but there are corrupt police, corrupt lawyers, and even corrupt leaders of the church. There are also many honest police officers. Therefore, let's put corrupt politicians in perspective. Okay? This is a red herring. Okay? So, it find way to avoid the opposing argument rather than addressing them. So, it says that let's put corrupt politicians in perspective. No, it means that we look at corrupt politicians in a different way. Okay? Example number 2. I know I forget to clean the toilet yesterday, but nothing I do pleases you. Okay? This is a funny example. So, to avoid being charged as not cleaning the toilet yesterday, he said that, anyway, if I clean or I do not clean the toilet, it will not make you happy. So what's the point of cleaning the toilet? Okay? So that is an example of a red herring fallacy. Another example of fallacy is slippery slope. So you can do this one, read them, and then strawman fallacy, almost the same as the red herring fallacy, and that's the end of the discussion. So I will put a link on the LMS for a quiz of these topics here. So let's end it here. Let's end our discussion here, and I will put this video on YouTube. So goodbye and thank you.